All right, now we're going to start talking about what happens when investments or loans or things like that are compounded more than once per year. That's where we have to be able to figure out what the annual effective rate. So imagine you want to invest some money into a bank account that pays 10% compounded semi-annually. What this means is this doesn't mean that you're getting 10% interest at 6 months and then 10% interest again at 1 year, which would basically just make this twice as good. Like that would be the same as having a 2-year investment at 10% that is just compounded annually. That's not what we're talking about. When you see this compounded semi-annually here, basically what it means is you take the number of times that you're compounding, in this case semi-annually would be 2, and you divide it by this 10%. So we get 10 divided by 2 is going to give us 5%. And however many times in the year you're compounding, this is the rate that you're going to get in your interest. So basically 10% compounded semi-annually is going to pay you 5% interest after 6 months, and then 5% interest again compounded, but after 12 months. You can imagine if we're compounding quarterly, we're going to have 10 over 4. We're going to have 4 payments, so the rate that we're paying out is 2.5%, but we're going to compound this 4 times per year. So that, just making sure that you see that compounding quarterly isn't 4 times as much money as, compounding once a year. It's just a little bit better. And we're going to get into why this is. So annual effective rate, I, what we have here is 1 plus R over M, where R is the interest rate that you're given, so that would be this 10% here. M is the number of compounds per year. If it's semi-annually, this number is going to be 2, right? That's what we did right here, 10 over 2. Or if it was compounding quarterly, it's going to be a 4. And then up here we just have M times N. What we're doing is we're just going to do this for 1 year to find the annual effective rate, so that will just become a 1. And yeah, we'll be able to solve this problem. So what we want to do is we want to find out, if we're compounding at 5% twice, is that better than compounding at 10% once? Well, obviously it'll be a little bit better, but definitely not double. Well, let's do this. So we're going to have our formula is for I, maybe we'll change color. So we're going to have I is equal to 1 plus 0.1 over 2, and M times N, so we'll have 2 times 1 all minus 1. This will reduce to, we will have 1.05 squared minus 1, and we'll get our annual interest, or annual effective rate is actually going to be 0.1025, and we can also write this as 10.25%. So basically what I'm saying is if you compound 10.25% annually, so just once at the end of a year, you're going to have this, that would be exactly the same as compounding 10% semi-annually, so paying out basically 2 payments of 5% and then compounding them. So let's just do a little rough sketch here without using this formula, and I'm going to show you why this works. So imagine you have $100, and what you want to do is you're going to compound semi-annually. So up here we'll have years. We'll have half a year, 1 year, 1.5 years, 2 years. Let's go up to 3 years. Okay, 2.5, and then 3 years. So each time we're compounding, we're basically just going to be adding on a 5%. So you just multiply times 1.05. Right? So that would be this 100 times 1.05. Well, actually, let's fill it in as we go. So that would be $105. 105 times 1.05 is going to be $110.25, right? So all I've done here is I've just added on 5% of the 100, and then I've added on 5% of this 105, and you see that it's, we've actually made a little bit more than 10% here. Okay, so we're going to continue this on, so we'll just keep adding, multiplying by 1.05, which adds 5% onto this total. So we will get, after 1.5 years, you would have $115.76, and we'll just do this here. You just always add or multiply by 1.05, and I'll just fill in the rest of the values so you don't have to listen to me talking. Okay, 121.55, we'd get 127.63, and lastly, after 3 years, you'd get $134.01. Okay, that's just doing it without the formula based on what I've told you here. So now let's use the formula and find out if this is true. So what we want to do is we use the future value of a compounding interest investment. So that is future value is equal to present value times 1 plus I, this is the annual interest rate, times the number of years. So for n equals 1, let's do n equals 2 and n equals 3. Alright, so we're going to get a present value, so we will have 100 times 1 point, and remember we said this is compounding semi-annually, and we found this to be 10.25%, so 1.1025, right? That's just 1 plus 0.1025 to the power of 1. Okay, and this is going to give us, if you do this in your calculator, well, you don't even need to raise it to the power of 1 actually, and you can just see that this is going to give us $110.25. Okay, so now if we had 2 years, we'd have 100 times 1.1025 squared. If you punch this in your calculator, square this first, multiply it by 100, and we're going to see that we're actually going to get the same thing. We're going to get $121.55. And lastly, if we have n is equal to 3, we have 100 times 1.1025 to the power of 3 for 3 years, and we're going to get a value of, it'll be exactly the same if you cube this and then multiply by 100, you will get $134.01. So there you go. That's a little bit of explanation about why this annual effective rate works the way that it does. And sometimes this is helpful to look at this this almost sort of table that we've made just to understand that, again, if we were compounding quarterly, this we'd be multiplying by 2.5% each time instead of 5%, but it would be 4 times a year instead of twice a year. All right, I'll see you in the next video, and we'll go over comparing some different compounding periods on the same investment.